So let's begin with deception detection. And the detection problem is something like this. So I'm going to show you two product reviews, one of which is a fake product review. And both of these come from the deceptive opinion spam corpus. And I want you to just look through these briefly and see if you can tell which is the fake one. Right, so here's the first one. I'm not going to read the whole thing to you, right, but I'm going to sort of highlight salient things. These are both hotel reviews. I only stayed out with my boyfriend for one night. I enjoyed my stay. The staff was friendly. The hallways and ballrooms, etc. were elegant. Room service was quick, good options. The staff was able to extend our checkout time for an extra 1 to 2 hours. Great location. Walking distance from all these different places. A quick cab ride from this one. If I were in the city again, I would love to stay there. That's the first one. Here's the second one. The Hilton in Chicago was awesome. The room was very clean. The staff was professional. One of the features I liked was that I had both wire and wireless access. It helped me a lot. Food was very good. Quality was great. There was also a flat screen in my room. Awesome. Hotel was located. So these are actual reviews. So these are the actual, these are the actual typing. And the middle of a lot of restaurants with thin dining, right? I enjoyed the gym. I would stay again. Which of these is fake? That's the detection problem. Okay, so I don't know if you have a sense of this, which one you might think is fake, but in fact, it's number 2. That's fake. Here's another example, this time from an opinion. This is from the essays corpus. One of these is true, one of these is false. They're both going to be talking about the death penalty. So here's the first one. The death penalty is very important as a deterrent. We live in a society, not as individuals. Some restrictions on our actions. If a person doesn't adhere, he or she forfeits her life. Why should taxpayers' money be spent on feeding murderers? That's 1. Here's 2. I stand against death penalty. Again, these are actual things with actual, the way that they wrote them. It's pompous of anyone to think they have the right to take life. No court of law can eliminate all possibilities of doubt. Some circumstances may have pushed a person to commit a crime. Otherwise, severe punishment. Right? Okay. Which of these is fake? It turns out it's 1. It's the first one. Here's sort of a final example. A fake interview answer to the question, please describe your educational background, which comes from the deceptive interview corpus, right? So these are people giving answers. Either they're giving true answers or they're giving false answers, right? So here's the first one. So these are real time. These are speaking out loud. So you may see more stops and starts and incomplete utterances, okay? Well, I completed my master's degree in business admin, hopefully going to be completing one for my doctorate, December of 1990, U of A, money in the family situation when I have time and money and work allows and everything else. Where did I complete that? I did that in 87, took some time off, went back here in Tucson. First answer. Second one. I have a bachelor's of arts in education, associates in accounting, computerized bookkeeping, artisans training and crafts, 18 years of formal school, 45 years of practice. I think a person who wants to be a teacher has to be very dedicated. As for accounting, that's just wisdom. I happen to be a creative fidget when it comes to crafts. Which of these is fake? Well, it's number 1. And the point is, it actually isn't that easy to tell, okay? But it turns out that we can get reasonable detection performance when we train and test in the same content domain. So for example, if we train on hotel reviews and test on hotel reviews, we can get an F score, which is a balance of precision and recall ranging between 0 and 1, near 1, like 0.912, right? Like it's pretty good at detecting the bad ones, right? And if you actually look at fake positive book reviews, you can get like 75% F score, 0.752 detection, which is, pretty good, right? Because 50-50 is kind of where chance is. Right, so that's pretty good, the same content domain. In the area of fake opinions, actually, we can get between 0.715 and 0.850 F score when we train and test on the same kind of content for opinions about abortion, the death penalty, and best friends. It's pretty good. In the area of interviews, actually, we can get 0.917 accuracy on children's deceptive interviews about a minor transgression. Again, training and testing on the same content. But performance drops a lot when testing on a different content domain, when training does not equal test. And even when, in some cases, it doesn't seem like we're changing a lot. So, for example, if we train and test on hotel reviews, we can get 0.912. But if we train on hotel reviews and test on ones where the valence is changed, so we train, say, on positive 5-star reviews and test on 1-star reviews, now we drop to 0.7 to 0.83, where before we were at 0.912. That's just changing the sentiment, really. right? If we actually change the service that was provided, if we train on hotels and say test on restaurants and doctors, now we're dropped to 0.679 to 0.784 from 0.910, so getting quite a drop. If we in fact train and test on opinions with different content, we go from 0.7 to 0.85 down, say train on death penalty, test on abortion content, to 0.66 to 0.70, right? Like dropping, definitely. And for example, if we have the same content, a children's interview about a minor transgression, the same minor transgression, we're at 0.917, but when trying to detect false court testimony where content is really variable from case to case, now we're at 0.63, right? So the takeaway is when we change content domains from narrow changes or broader changes, things get worse, right? And so the goal is maybe try to find something that works better at deception detection when we don't have similar content to train on, right? Because if we have similar training data to what we want to test on, it seems like existing techniques are probably pretty good. It's when the training and test are not the same that we run into troubles. So what features might generalize better across content domains? And it turns out that general purpose linguistic features often used in natural language processing and NLP, like say these word-based engrams, the type of thing we saw before, and rules based on syntactic structure have done really well within domain. That's one sort of clue. Now, in the psychology of deception, the amount of specific detail is thought to correlate with psychological mechanisms underlying the generation of deceptive language in any domain. In fact, this is the basis of a lot of different training programs, right, that people use to detect false testimony, right? So information manipulation theory, information management theory, criteria-based statement analysis, reality monitoring, right? Like specific detail is something that is correlated. In particular, less specific detail is correlated with making things up, with deception. So the problem is that specific detail is kind of a squishy concept, right? You're like, what is a specific detail? Well, humans can be trained to recognize them, but it seems currently hard to automatically identify what a specific detail is, right? But let me just show you that it's not so crazy for humans to be trained or to get a sense of like what specific details are. So here's the product review, one of the product reviews that we saw earlier, and I'm just going to scan through and look for things that maybe pop out as being specific details about this hotel stay rather than sort of general things you can say about hotels. So for example, the staff was able to extend our checkout time for an extra 1 to 2 hours, right? That's a specific time frame. And they talk about location, but they talk about specific places that are across the way, right? So both of these things seem like specific details, right? And so this is pretty much what we did on this project. So we used our human powers to get squishy specific details examples. In particular, we looked through a lot of different text samples of truthful and fake deceptive samples of text and tried to manually identify examples of specific details. And then once we got examples of specific details, we tried to leverage these general purpose linguistic features to come up with some linguistically based heuristics that do a good enough job of capturing these bits of language. So in particular, what we ended up with were 7 linguistically defined specific detail features that can be incorporated into your favorite machine learning classifier. So just to sort of demonstrate what these looked like, we have take this sample of text. This place is a haven of cool, uncluttered comfort in one of the greatest cities in North America, just 2 minutes from the nearest airport shuttle. Okay, so one of these specific detail features had to do with the prepositional phrase modifiers. So of cool, uncluttered comfort, of the greatest cities in North America, from the nearest airport shuttle, right? Prepositional phrase modifiers to some content, the number of these and the length of them, longer versus shorter. We also looked at adjective phrase modifiers, so cool, uncluttered comfort, greatest cities, nearest airport, number and length of these in a message. Numbers, just like actual numbers, so one of the greatest cities, just 2 minutes from the nearest airport shuttle. Proper nouns, like North America. and consecutive nouns, like airport shuttle is 2 nouns in a row, or the airport is modifying shuttle, right? So these are the linguistically defined specific detail features, this conglomeration of the general purpose linguistic feature and the psychologically motivated concept of specific details. And so the first thing we did was a sanity check. Actually, it's like, turns out that most of these linguistically defined specific detail features do in fact appear significantly more frequently in truthful language samples across all 3 content domains, that is product reviews, opinions, and interview answers. So it's not crazy to think that they might get us some mileage, right? So the question then is, will they be effective when cross-domain generalization is what we're after, when the training is not the same as the test, right? And let's find out by incorporating them into, a pretty good symbolic classifier, a support vector machine. So we also, of course, want to have something to compare against. So we'll compare SVMs using only our linguistically defined specific details as features against SVMs of 2 different kinds. One, those that just use n-grams, these general purpose linguistic features, which have done really well in previous within content domain work. And we'll also compare them against SVMs that have access to both n-grams and linguistically defined specific detail features, like all of that information, right? And the first thing is sort of another kind of sanity check, or a baseline, is how well do these different approaches do within domain, where the training is the same as the test. And we use 5-fold cross-validation to do this, and the corpora really that we use for these, we use our deceptive opinion spam data, so positive and negative valence hotel reviews. We use the essays corpus, and these are short opinion essays on abortion, the death penalty, and best friends. And we have the deceptive interview corpus, which is real-time answers to 12 job interview questions, like the educational background we saw at the beginning. And so we'll also separate these out by F-score performance, that is the balance of precision and recall, on truthful versus deceptive samples, because they actually give us different patterns as we go along. So to begin with, let's start with product reviews. So for product reviews, n-grams on their own work pretty well, right? 86 to 87 F-score. And adding in linguistically defined specific details as like features the classifier could use really doesn't make much of a difference. We're still right there at 87 F-score. And there doesn't seem to be much of a difference at all between performance on truthful versus deceptive reviews. Now, in comparison, specific details on their own do not do so well. Witness how this is now 0.55 for truthful and 0.66 for deceptive. Like there's definitely a drop in performance, and there seems to be worse performance on truthful reviews. Okay, so that's our first data set. Our second one is the opinion essays. And here we're really seeing the same pattern, though overall performance drops for the SVMs that either only use n-grams or use n-grams and specific details. Now we're in the 70s, right? But specific details are kind of still where they were, which was not great, but at least they didn't really go much lower. For the interview answers, we see the same pattern again, where the overall performance for our n-gram-based SVMs really, now we're down in the 50s, which is really not looking fabulous, right? And the SVM relying only on specific details now starts to show rather a different pattern, or at least an exacerbated pattern, right? So we're doing better on deceptive versus truthful. In fact, truthful is just abysmal, actually, right? But we're really not seeing any drop in performance across these content domains. I mean, it was doing in the 60s, still doing in the 60s on deceptive, in this case, deceptive interview answer detection. Right, so I think the takeaway at this point, if we're just talking about, training and testing being the same type of information, if you have training data in the same content domain, n-grams will work well enough on their own, right? They really will, although performance does depend on the content domain, and we saw that drop going, through these different data sets in performance. But specific details on their own may get you a boost on deceptive performance when the content domain is hard. For n-grams, we had really poor performance in the 50s down here for the n-gram based approaches, but specific details on deceptive performance were still actually right where they were before. So, okay. But Now let's see what happens if we have some narrow changes in content between training and test, our first sort of cross-domain challenge. So we're going to look at changes in product review valence. So we're going to train on positive and test on negative hotel reviews, or train on negative, test on positive. And we can also go a little broader with our opinion essay topics. So we can train, say, on abortion and best friends, but test on death penalty. Train on abortion and death penalty, test on best friends. Train on best friends and death penalty, test on abortion, right? You know, slightly broader, but still sort of the same type of thing you're talking about, an emotionally charged topic. And let's look, right? So when only the valence of the review changes, SVMs incorporating n-grams still do okay. There's a performance drop compared to what we saw before with in-domain, but we're still, in the 80s, or maybe the 70s, right? Like, that's fine. There's no obvious gain, certainly, for allowing the SVM to also rely on specific details. I mean, the scores seem really, really similar. But if we look at the SVM that can only use specific details, actually I should say this, we also see better performance on truthful reviews, right, compared to deceptive, a little higher. If we only look at specific details alone, we again see a pretty significant performance drop, especially on truthful reviews. But relatively speaking, it's the deceptive reviews that get better performance, right? That's the same as we saw within content domain. For more substantial content change, like when we're actually changing the essay topic, n-gram approaches have more significant drops in performance. Now they're maybe in the 50s, 60s, lower 70s, right? We're seeing pretty significant drops, but they're also doing better with deceptive essays, where before they were doing better on truthful ones, so different patterning. And specific details alone, if we look at those, how do they do? Well, they can drop their performance some, right, 63 to 54, or a lot. Oh my goodness, 0.39 is terrible. But sometimes they perform better on the deceptive essays, and the performance on the deceptive essays, when they perform well, is about the same, right? It's still in the 60s. It's not getting worse, right? In fact, over here, strangely, for whatever reason, they're actually doing better on truthful ones, again, in the 60s. That makes them comparable to some of the performance, sometimes better, actually, than a lot of the truthful performance we saw from the n-gram-based approaches. Well, what do we take away from this? I think the takeaway is if the change in content's fairly minimal, like you're just changing like how positive or negative you feel about a hotel, n-grams alone will still do well enough, though not as well as when there's no change in valence like this. If the change in content's more substantial, right, you're down here and you're changing, say, the content of your emotionally charged topic, there could be some benefit to incorporating specific details with your n-grams or using them alone, right? But now let's see what happens if we have some more substantial changes in content between training and test. So in particular, what we're going to do is, say, train on product reviews and essays, but test on interview answers. So really changing both the content and the form of what we're encountering. Or maybe we'll train on essays and interview answers, but test on product reviews. Or train on product reviews and interview answers and just test on essays, right? Like really changing the content and form quite drastically, okay? So here is what we see. First of all, performance overall pretty much plummets, right? Where 60s is like really the best we can do, and certainly on the deceptive samples, man, it is just wretched for the n-gram based approaches. 29, 39, this is below chance. This is really bad, right? Now, in contrast, specific details alone do much better. They're, at least in two of these cases, still in the 60s. In the case where they're in the 50s, they're still a heck of a lot better than the n-gram based approaches, even though performance on truthful data, in contrast, suffers quite a bit, right? It's just not as good, right? So these differences are really due to actually deceptive recall performance. Specific details has relatively, or in the case of these two, actually great deceptive recall. So 80s, right, compared to 42 or 19, right? And even 49, which you're like, how great is that? But it's better than 18 and 31, right? So specific details have this very particular behavior pattern of doing great on deceptive recall, but this comes at the expense of truthful recall, right? Truthful recall is abysmal, especially compared to the n-gram based approaches. And even this one where it's actually much better, it's still much worse than the n-gram based approaches, right? So truthful recall suffers. Okay, so I think the takeaway here is if the change in content is really substantial, there can be some benefit in detecting truthful data when incorporating specific details, but n-grams alone are probably good enough for truthful data, right? However, for detecting deceptive data, the changing content's really substantial like this, there's significant benefit, there can be, to relying just on specific details alone. Okay, and in particular, when we dig into like which specific details these classifiers were relying on that produce this pattern of behavior being just like really good at detecting deception, right, at catching the deceptive cases, right, it was the number feature. It was by far and away the most used. So the 2 in 2 minutes, right, that exact number, which is actually pretty easy to pull out, right? So the things that I think we learn from this is that general purpose language model features like n-grams are actually great. You know, we knew this really, but are great for detecting deception within domain. We showed that again, but their performance really drops precipitously the more the content changes between training and test. Okay, and even within content, sometimes it drops a lot. In contrast, linguistically defined specific detail features, especially exact numbers, shine when there are dramatic content changes between training and test, especially if it's more important to make sure that no deceptive data slip through undetected. That's what deceptive recall is really getting at. We don't want to accidentally let those slip through as truthful. But this comes at the expense of often marking truthful data as deceptive, right? So I think the takeaway is something like this. If your training data are pretty different from the test data you have, then where you'd like to be able to detect deception, and if it's more important to you not to let a false statement slip through without, for example, further monitoring by humans, then incorporating linguistically defined specific details into your features is probably worthwhile.